Hello. So we will discuss chapter 7, section 4. We already discussed, in our previous video, we discussed case 1. So today we're going to discuss case 2. So, case 1 was about the divisor being a product of distinct linear factors. So we go to case 2. So case 2 is that the divisor Q of x is a product of still linear factors where some of them are repeated. So here we have a repetition. Like here you have quantity x minus a squared. It means basically you have quantity x minus a times quantity x minus a. So the factor x minus a is repeated. Okay. Similarly, you have quantity x minus b squared, which the repetition of x minus b. So that's case 2. So when you see this, then you're dealing with case 2. So these are distinct because a and b are not equal. So we have two different factors here. Now, when you're dealing with case 2, first, let's discuss the partial fraction decomposition of case 2. So we have a p of x over q of x, which is equals to p of x divided by q of x. Q of x is given as quantity x minus a squared times quantity x minus b squared. So to do the partial fraction of this, we do the same thing as we did in case 1, only here we're going to start with a over x minus a. Here we have quantity x minus a squared. So first we start with x minus a, and then we move to quantity x minus a squared. Because this stop is square at 2, then we move to the next one. So you have a over x minus a plus b over quantity x minus a squared. Plus, then you go to the next factor, you do c over x minus b plus d over quantity x minus b squared. So this is the partial fraction decomposition when we're dealing with case 2. Of course, uppercase A, B, C, and D are all constant to be found, to be determined. Now, in terms of integration, after doing this partial fraction decomposition, so to integrate p of x divided by quantity x minus a squared times quantity x minus b squared, we first replace this rational function with its partial fraction decomposition. So that makes us having, in this case, we have 4 integrals to evaluate. The first one, clearly, this is case 1. We already did this. You just what you do is bring a outside and then integrate 1 over x minus a, which we know is going to be a times natural log of absolute value of x minus a, plus k1. K1 here is constant of integration. Now for the second one, to do it, we move b outside because it's number. So here we're going to deal with the integration of 1 over quantity x minus a squared. But how do you integrate this? We're going to use the u substitution. So we're going to let u be x minus a. So du is dx. So that means this integral is going to become 1 over u squared du. And to integrate 1 over u squared, you needed to change 1 over u squared to u raised to negative 2. So you can apply the power rule of integration. So you're going to have b times u raised to negative 2 plus 1 over negative 2 plus 1 plus k2. And then when you get this, then you can bring u to the negative 1 at the bottom to change the negative exponent to positive exponent. So you end up with negative b over u plus k2. And then you can go and replace u with x minus a, and then you get the answer for the second integral. The third integral is like the first. Okay, it's still natural log of absolute value x minus b. The fourth integral is like the second integral. So you end up with negative d over x minus b plus k4. Okay, and then you can just add all of them to get the result. So let's go to an example. So here we are asked to evaluate the integral. The integral of x minus 2 over quantity x plus 5 squared times quantity x minus 1 dx. So this is a mixed case. So you have, so the first, when you look at quantity x plus 5 squared, that makes it case 2. But x minus 1 is just case 1. So you have a mixed case problem. So what do we do? First, we start with partial fraction decomposition. So we take x minus 2 over quantity x plus b squared times x minus 1. So do not change order. So if they give you, follow the q of x, the way it is ordered, just leave it as it is. So here we're going to start with case 2. Case 2 says, write a over x minus 5 plus b over quantity x minus 5 squared. Plus, and then we go to the next one, which is case 1, we just put c over x minus a. So this is the partial fraction decomposition of that rational function. So now we know we will have to find a, b, and c. So to find a, b, and c, as we said in all cases, you have to clear all fractions. You have to clear all the denominator. To clear all the denominator, you will always multiply this equation by q of x, always, for all cases. So q of x here is quantity x plus 5 squared times quantity x minus 1. So we multiply both sides. We multiply the left side, and then we multiply the right side. So we're going to multiply the denominator q of x by each of those partial fractions. So on the left side, we divide q of x by q of x, it gives us x minus 2. On the right side, the common factor is x plus 5. So we simplify x plus 5. We're going to remain with a times x, quantity x plus 5 times quantity x minus 1. The second term, here we divide x, quantity x plus 5 squared. We simplify that. So that leaves us with x, b times quantity x minus 1. And the last one, we simplify x minus 1. So that leaves us with c times quantity x plus 5 squared. So we have this regular equation. So we know what we're looking for here is to find a, b, and c. So first, we have this factor x minus 5. We find it's 0. So the 0 of x plus 5 is x equals negative 5. So we're going to take this new equation. We're going to evaluate it at x equals negative 5. So you plug in negative 5 for x, wherever x is in this equation. So negative 5 goes here, it goes there, it goes there, it goes here, and then it goes there. So on the left side, we're going to get negative 7. On the right side, this will be 0 because negative 5 plus 5 is 0. 0 times any number is 0. So this goes away, the entire thing. So is this. When negative x is negative 5, you get 0 times c. 0 squared is 0 times c is 0. So this goes. But only this, when x is negative 5, you get negative 5 minus 1, which is negative 6b. So you get negative 6b equals negative 7, which means 7 equals 6b. So b is a 7 over 6. So we get the values of b. And then we go to the second factor, which is x minus 1. We find it's 0, which is x equals 1. So again, from the same equation here, we're going to plug in x equals 1. So wherever x is, we plug in 1. So on the left side, we get negative 1. On the right side, we get 1 minus 1, which is 0, and then 0 times any number is 0. And then here, we plug in 1, we get 0 times b is 0. So the only thing that is left is that. So 1 plus 5 is 6. 6 squared is 36. We get 36c equals negative 1. So c is negative 1 over 36. So we got b and the c. We didn't get a yet, but there's no other factor that's where we can retrieve its 0. So we're done with the zeros. So, but we still have a left. We didn't find a. So that's when the choice will be yours. You can pick any value of x that is not the zeros. So that is not 1, and that is not negative 5, because we already used negative 5 for x and 1 for x. So you can pick any values of x, okay, different from 1 and negative 5. So what I did here, I pick x equals 0. So I go to the equation. So I evaluate this equation at x equals 0. You can pick any value. You can pick x equals 2, x equals -2, and so forth. It doesn't matter. So I will evaluate this equation to 0 for x. So I plug in 0 for x, wherever x is. On the left side, I get -2. On the right side, I will get, so 5 times -1, which is -5a. Here, you get -b. Over here, you get 25c. So you get this equation. But we already know b, and we already know c, because we already found them. So you go here and replace b by 7/6, and then c by -1/36, so that you can solve for a. So when you plug in those values of b and c, you then add like terms. Okay, so first you multiply 25, you bring 5 on the other side, it becomes, you bring -5a on the other side, it becomes 5a. -2 goes on the other side, the right side, it becomes +2. And then here you find the common denominator, and then you end up with a equals 1/36. So we got a, b, c, we got all those constant to be determined. So we go back to the rational function, we plug in a, b, and c, and then after that we go to integration. So to integrate x minus a over quantity x plus b squared times quantity x minus 1 dx, it basically means we're going to integrate these 3 partial fractions. So we move 1/36 outside. We end up integrating 1 over x plus 5, which is give us natural log over absolute value of x plus 5. Here let's do the last one. So we move -1/36 outside, and then we end up integrating 1 over x minus 1, which is just a natural log of absolute value of x minus 1. So for this one, we move 7/6 outside. We end up integrating 1 over quantity x plus 5 squared. We know we're going to use the u substitution. So u is going to be x plus 5. So that we're going to end up integrating 1 over u squared. We change it to u raised to -2. We already did this. So we know the answer is going to be x plus 5 raised to -2 plus 1 over -2 plus 1, which we can rearrange to become -7, because there's -1 at the bottom, so you get -7 over 6 times x plus 5. And then when you collect all of them together, and then plus k, it gives us the answer. So our next video is going to be on case 3. Thank you.